What we're going to do is today we are going to learn about the rules of differentiation. However, before we do that, we're going to do a couple little examples of finding the equation of a tangent line, finding the slope of curves. Right? We're going to do this using our calculator to get a little bit of practice with that. So, here's what we're going to do. Alright? First thing we want to do is we want to find the equation of the tangent line to y equals the sine of x plus 2, for x plus 1, when x is equal to 1. Alright? So, in order to find the equation of the line, we need to do two things. You remember what those are?
Find what?
You need to find the equation of a line. So, you need to know two pieces of information in order to be able to slope. Okay, so you know slope. Alright, what else? Into P. A point. Alright? We didn't know a point. So, we are finding a point where x is equal to 1. So, we need to find the y value, we just plug 1 in. Alright? So, the y value is sine of 1 plus 1 plus sine of 2. Okay, so we're just going to, on our calculator, find the sine of 2 real quick. So, we're going to find the sine of 2. Again, to sort of be all on the same page, I believe I have you guys set up to around some 3 decimal places. So we're going to go the sine of 2, and it's 0.909. So this point that we're looking at is 1.909. Okay. Now we need to find our the slope. And again, we talked about how the slope is found by just finding the derivative at a certain point. Okay? Well, we talked about how to do that in my calculator. Because right now, you guys don't know how to find the derivative of sine. Okay? So, what we do, just if you can remember this, to find the derivative, one quick way is to go math, and then do 9, so 8, not 9, math 8. Alright, we're going to find it with respect to x. X. We're finding sine of x plus 1. Alright, we're finding the derivative at x equals 1. Enter. So our slope is negative 4.16. Negative 4.16. Nope. Negative 0.416. We know our slope, we know our point. Now we're going to use our point slope form, or not point slope form, slope intercept form, and it is y minus y1 equals m times x minus x1. Alright, so it's y minus our y1, which is 0.909. That's equal to our slope, which is negative 0.416 times x minus x1, which is 1. And that right there is the equation of the line tangent to the equation or the function y equals sine of x plus 1 at x equals 1. Alright? So, what is that? So what we could do, since you see this, is you graph this. Now, to graph this, we're going to have to do a few other extra things. If the y equals, you go sine x plus 1. Right? Between 7. What I would need to do is I need to find the derivative here because I can't just use these numbers because these are rounded. So I'd have to go second trace in the derivative, so 6 at x equals 1. So that tells me that, so I'm going to store that as n. But what we could do is we can graph this. We'll get a pretty good estimate. It's going to be well, the negative 0.416 times x minus 1, and then it would be plus sine 2. Okay. Let me prove this. That's what our graph was kind of defining there. Okay. So, looking at one other problem, it says find the slope of the curve y equals secant x squared of x is equal to negative 0.25. Alright, so we're going to do this on the calculator again. That's one finding when we look at the graph. The graphing screen, one where we find it for the home screen. The home screen system we did not make. So to do this, the first thing we're going to have to remember is that secant is equal to 1 over cosine. So it's 1 over cosine x squared. So if I use this into our calculator, we would have to go, first of all, go back here, figure this out. We need to go 1 divided by cosine x squared. Graph. So that's easy. Alright, so we want to know the slope of the curve, and x equals negative 0.25. So to do that, again, we're going to go second trace. We're going to find the slope, which is our derivative, 6. We're going to negative 0.25. Better. So our slope would be negative 0.021. So dy dx is equal to negative 0.031. And the slope. Yeah. So you can go back and see the calculator. And then for the home screen, do it again. We just have to go back here. You hit math 8. So we would expect x, and it is 1 divided by cosine x squared. And it's going to be at x equals negative 0.25. We should get the answer. Negative 0.02. Okay. That's how you can go about doing that really quickly on the calculator. Then you guys get more practice with the calculator. You can check most of your answers tonight. So that being said, that's all great, I think. But what we want to know how to do is find the derivative of the function by hand. Alright? And by hand, I mean not that we have to do a bunch of limit stuff, because that is doing a lot of work that is in a way unnecessary. Alright? So what I'm going to do is I'm going to show you a couple of rules first, and then we're going to do some examples where we see how to use these rules. Okay? So, first rule that we have is the derivative of a constant. function is where you have something that's just like y equals 7, or derivative, or f of x equals -2. Alright? And we represent the constant of that as c. So what this says is the derivative with respect to x of a constant function, alright, is equal to 0. You kind of saw that already. Alright? We did that on Friday. We saw that the derivatives of a function, we sort of saw how the rule worked a little bit. We saw the constants would disappear. That's because of this rule right here, where it tells us that the derivative of the constant is equal to 0. Alright? Now, there's another one. Let's say you have, so the next thing is the constant often rule. Alright? And what that is it says the derivative with respect to x of c times some function, we'll say f of x, alright, is equal to c times the derivative with respect to x of x. Okay? So what that allows you to do is to pull out the constant from the front of the function and take the derivative of the function. Now, this right here, we're going to use this, but the way we're going to use it right now is going to be sort of like, the way we're going to use it is it's going to be sort of intuitive. It's not going to be explicitly said we're using it. That would be a rule that helps us more when we start taking the derivatives of more complex functions. Right? Now, power rule is the one that you guys sort of saw on Friday. You guys sort of came up with. Right? It says that if you're taking the derivative of x to the n power, right, it's equal to n times power equal to n times x to the n minus 1 power. Alright? Which n is just the x. Okay? You guys sort of came up with that on your own. Now, the last one that we have is the sum of the difference rule. Right? And this says if you have you're taking the derivative of something that looks like f of x plus or minus g of x. Right? This is equal to the same thing as saying the derivative with respect to x of f of x plus or minus the derivative with respect to x of g of x. So again, what that allows you to do is if you have a complex function and you can take the derivative and the different parts of the function, like adding and subtracting together, you can take that and you can take the derivative of each piece separately. Okay? And again, right now, this is going to be something that we don't necessarily, we're going to use it, but we're not going to explicitly say, okay, we're using this. It's just we know that this rule exists, so this allows us to take the derivative of what we do. Right? So right now, again, there's gave these rules. Probably don't really understand what they mean and how to use them. So what we're going to do is we're going to look at the examples that use these to find the derivatives of functions. Okay? Again, on Friday, we looked at how to find the derivative of these examples. No more of that. It takes too much work. So, functions up here. Yep. So, what I want us to look at here is this. Okay? We're just looking at this first problem right now. So y equals 3x to the 4th minus 1/2 x to the 3rd power plus 12x squared minus 4/3 x plus 19. Okay? Now, it may look complicated just because it's a big long function. Alright? But what we know is that the sum and difference rule of differentiation, alright, says that we can take the derivative of each one of these pieces separately. Those are all subtracted and added to each other. So we can take the derivative of this, and subtract the derivative of that, add the derivative of that, and subtract the derivative of that, and add the derivative of that. Alright? So, if we look at this, we notice that these are x's raised to the power. Alright? Now, one way that we can think of this is 3x to the fourth, and we can break that up. Alright? So, if we go down to the side, this, and I know you may have seen this eventually, you don't know what to do, but we have 3x to the fourth. Okay? What we can really do, we want to take the derivative of that. So, the derivative of 3x to the fourth. This is equal to 3 times the derivative of x to the fourth. Okay? What allows us to do that is the constant multiplier. Now, the power rule states that take the derivative of x to the fourth. We're still going to have this 3 times. Now, here, what you do is you look back at the power rule, it's x to the fourth power. So you have x to the fourth power is equal to 4 times x to the 4 minus 1 power, which will be 4 minus 1 will be 3. So what this is saying is that 4 x to the 4 minus 1 power, which is the third power. Well, that's just equal to 3 times 4, which is 12 x cubed. Alright, now that's the long, in-depth process of why is this derivative equal to this. Now, obviously, we don't want to have to do all that side work. And what we see is that we just have to multiply and figure it. So what we do instead is we say, okay, I'm going to take my x over because the power rule says that we have x to the minus 1. So, what we have here is, in fact, what we can do is say, take this 4, we have to multiply it by the coefficient. 4 times 3 is 12. X. We subtract 1 from the x one. So 4 minus 1 is 3. Then, we're going to move on to the next piece. Alright? So this is minus 1/2 x to the third. So minus, again, what we do is take that 3. We're going to multiply it by the coefficient. So 3 times 1/2 is 3 halves. X. What do we do to the next one? Then we're taking the derivative. What do we do to the next one? We do 3 minus 1, which is 2, so it's x squared. Plus 2 times 12, which is 24. Right here, we take the 2, subtract 1 from that, that's x to the first power, which is x. X to the first power is. This is minus 4/3, x has an exponent of 1. So we have 1 times, this is minus 1 times 4/3, which is 4/3. X, or 1 minus 1 is 0, so the x to the 0 power is just 1. So then x goes away. And you have plus 19. Well, we have a rule that says that the derivative of any constant is equal to 0. 19 is a constant. So the derivative of 19 is 0. So our derivative is 12x squared, or 12x cubed, minus 3 halves x squared, plus 24x, minus 4/3. Questions? No? So, we go to the next one. Alright, now, notice in this case it says dx. That's just because my variable is s. Alright? And then my variable is x. So, 19 is a constant, again, a constant is what it says, the derivative of any constant. So, this problem, alright? Now, I'm going to rewrite this problem first before we look at it. 3s squared, or 3 divided by s squared, really, we can't work with, right now we can't work with something in the denominator right now. Alright? So if we really rewrite that without it being in the denominator, so what we really have is the derivative with respect to s is equal to 3 times s to the negative 2 power plus, now this right here, there's something in the denominator, really what that is 1/5 times s squared. There's the property of excellence where you can take a term that has an excellence and written in the denominator and move it into the numerator, which just makes it excellent. Alright? Now, we've done 5 words.
Say that one more time.
The properties of one property of excellence says that if you have a positive excellence in the denominator, you can move it up into the numerator and it becomes a negative excellence. Right? The reason we do that is because right now we don't have the tools for it to take this derivative without the tools. Right? So we do the exact same thing. Right? The derivative of this. So ds is equal to. You take your exponent and multiply it by the coefficient. Negative 2 times 3 is what? Negative 6. So you have s, and negative 2 minus 1 is negative 3. So negative 6 times s to the negative 2 power. Plus, you have 1/5 times s squared. The derivative of this is going to take the 2, multiply it by the coefficient. 2 times 1/5 is 2/5. Right? Times s, 2 minus 1 is what? 1, which is s. That's our derivative. Now there is some cleaning up we could do there, but here's the thing. On the AP set, you don't have to. Why try to clean that up? Then risk making a mistake. You don't have to clean it up. Right? By cleaning up, all I mean is that we could say this is equal to negative 6 s cubed plus 2/5 s. Alright? You don't have to do that. Once you get your answer that's correct, you can just leave it that way. Alright? The AP test does not penalize you for leaving the derivative like that. Okay? Any questions on that one?
No.
Are those rules making sense so far?
Yeah. Basically,
Yeah.
yeah. So for every problem where we have to use like every step for one to work, for every rule,
I mean,
no.
when you're, so what's the concept? But, I mean, you're using all these rules, you don't have to, it's not like you're using, these rules tell you, these are the rules that say, yeah, this is why you do this. But once you get to know, like, exactly, once you're really good at it, you don't have to, you won't even think about it. You just know, okay, this is how to do it. And on this one, I wouldn't even think about it. I just know it's 12x to the third minus 3 times x squared plus 24x minus 4 thirds. Because you get that, you're going to get that little. Alright? So, here we go. Take it, it's a part of it. Okay? Now, this one requires us to sort of rewrite this one a little bit. You guys see anything you might want to rewrite? You don't want to change that to something? You have anyone have any ideas what we're going to change it to? Right now, all you guys pretty much know how to work with is if you have something raised to the power. Right? This right here doesn't make it raised to the power. Until you realize, maybe remember, that the square root is actually the exponent of 1/2. Right? So the square root is the same. If I say, the square root of 4, that's equal to 2. That's also the same thing as saying 4 to the 1/2 power. Okay? So f of x is actually x plus 1 to the 1/2 power. Right? Plus, right here, I have a variable with an exponent in the denominator. I don't like that. That makes, I don't know how to do stuff. We don't know how to find the denominator without throwing the x in the denominator yet. We don't know that. So we will take this x to the third and bring it up to the numerator and make it negative. So it's going to be 5 halves x to the negative third. We have minus x to the square root of 3. Okay? Do not think too hard here. Okay? So what we're going to do, alright, we are going to take the derivative of this. So what do we do here? The power rule says that we do what? So 1/2 times 1 is 1/2. Alright? Times x plus 1. 1/2 minus 1. Negative what? Negative 1/2. Negative 1/2. Alright? Plus 5 halves times negative 3. That's going to be negative 15 halves. Negative x is negative 3 minus 1. Negative 4. Okay? Then we have minus x to the square root of 3. So we have a minus 1 here, we have a square root of 3. So minus 1 times the square root of 3 is going to be minus square root of 3. Alright? We have x. And then what's the square root of 3 minus 1? Good. It's just not going to do it. Square root of 3 minus 1. That's all we're going to put. You don't want to miss making a mistake. Right? So just put square root of 3 minus 1. Now, could we simplify this? We could rewrite this a little bit. But I'm not going to really change it. Because right now, I just want you guys to leave it in.
So that's the answer.
This is the answer. The only thing I would say is you would see the answer for all the first questions. It's plus negative. So the only way I was going to simplify it is 1/2 x plus 1 is negative 1/2. Plus minus is just minus 15 times x to the negative 4 minus square root of 3 x square root of 3 minus 1. So that should be right. Alright. Again, eventually, I want you guys, we'll talk about what to simplify, how to simplify that. Typically, we don't like negative exponents. Okay? So, just so that you can see what it looks like. First of all, I said we don't like negative exponents. So this is x plus 1 is negative 1/2. We move that down to the bottom. So it will be equal to 1 over 2 times x plus 1 is 1/2. And then minus 15 over 2 x to the negative 4 power would be minus 15 over 2x to the 4th power. And then this one I just would need is minus square root of 3 x to the square root of 3. Alright. So that'd be one way to simplify it. The only other way that you can change it around is instead of having x plus 1 to the 1/2 power, have the square root of that. Okay?
So,
What? so far. Again, it's all the exact same stuff. Multiply by the next one, multiply the coefficient by that, subtract 1 from the next one. So, let's look at some of these. Alright. Yep. Be careful with these. So we're going to look at this first one. Derivative of 4 pi squared. Alright? Derivative of 4 pi squared.
Oh my God.
Smart. What do you think this is? What do you think we do? What do you think we do?
Oh, no.
You're saying 2 times 4? So then subtract 1 from 2. So it'll be 8 pi to the first power. Or as you say, you said 2 times 4, that's 8. 8 pi. Subtract 1 from 2, that'd be 1. Here's what I think. So is this a variable?
I don't know the number.
This is a number. So 4 pi squared is really what? Constant. What's the derivative of constant? Zero. So the derivative of 4 pi squared is 0. Good. Alright. Now, just so we all know, E, right there, that's a number. Okay. Euler's number, like 2.714 or something like that. So we have the derivative of E squared times X.
We put the 1
We want 1.
we put the 1 with the right thing.
So, X1.
Yeah.
Okay, so 1 times E squared would be just E squared. No, we're not taking the derivative, we're taking the derivative of E squared X. Yep. So, the E squared, we take 1 away from X. So it would be 1 minus 1 is 0, so X to 0 power is what? No, 1. So it's E squared times 1, which is this E squared. Okay. And then, what about the derivative of X to the pi power? Don't think too hard. Just like you never heard of anything where it's to the square root of 3 power. And all we did was multiply by the square root of 3. Say again. X to the pi power minus 1. Missing 1 there. Minus 1. See that, Shemar? You need 1 by that. Good. That's it. What? Alright. Higher order derivatives. Okay, higher order derivatives. We talked about this before a little bit. Alright? So the higher order derivatives. So, notation. So if you see f of x, alright, we have our first derivative, which would be f prime of x. Alright? The second derivative would be f double prime. And I'm going to go one more. F, the first derivative would be f triple prime. Alright? And you can keep going. Alright? You can keep going forever. And you would have, so you have the first derivative, second derivative, third, fourth, fifth, keep going until you get all the way down to where, some functions go on forever. Other functions could end up being like, get going all the way down to 0, so we have that derivative is equal to 0. Alright? Another type of notation is to see, when you see like y equals, alright, so you have y. And you're going to have y to prime. And you're going to have y double prime. And then again, y triple prime, or y, the derivative of y. Alright, so you can take that and go on forever. 4th, 5th, 6th, 7th, 8th. You can take derivatives forever. Next one, you have, actually, so that's one way to do it. Another way to get y is to be, first derivative would be dy dx. Okay? Second derivative would be d2y dx squared. Dx2. Third one would be d3y over dx3. Okay? And then you can continue going on forever. Okay? Those are pretty much going to be the main notations that we use. Right? Now, so what I want you guys to think about here, I'm going to ask this question. Alright? Now I want you guys to think about what you might be able to know more derivatives. Alright? If I ask you to find that 314th derivative of x squared, what do you think that might be? Let me do it. I was just saying, I want you to find the 314th derivative of that function. X squared. I want you to find the derivative of x squared, and I want you to find the derivative of its derivative, the derivative of that derivative, and I want you to know it. Huh? What's the first derivative of x squared? So the first derivative of x
Oh, yeah, because of the line, yeah,
second derivative of x is what?
Oh,
This is the second derivative, 2. Right? That's a constant, huh? Correct. So this is, so that one third derivative is 0. So the derivative of 0 is 0. The derivative of 0 is 1, and just keep going. So 340. Actually, wait. Because it's multiplied by 1, that's 2. And then 1 minus 1 is 0, that's the power of 1. That's 2 times 1. So when you have that high of a derivative, all you have to see is that, okay, that after the third derivative, the derivative of x squared is 0. Therefore, it's going to be 0 for anything higher than the third one. Question? So, to find the first three derivatives, y equals 2 divided by x minus 4. Alright. So that means you want to find d1 dx first. So, what I'm going to do here is again, right now, you guys don't have the tools to figure out the derivative of this when leaving x minus 4 in the denominator. So it's going to be 2 parentheses x minus 4 is negative 1 half. Okay? So the minute, to find out the derivative of that, what's the first, what do we have to do? Yeah, so you're going negative 1 to the front, and multiplying by 2. Negative 1 times 2 is negative 2. And then, you still have x minus 1. And then you say, what are we doing with negative 1? There's our first derivative. We're done. Alright? Now we can find our second derivative. Okay? So, Akira. Here's our first derivative. The second derivative is the derivative of our first derivative. So how do we find the derivative of u by dx? First one we're going to do. I don't see this, I see two negatives. Okay, so I'm taking my exponent and multiplying by my coefficients, the negative 2 times negative 2 is positive 4. I still have my x minus 4. And then what I'm going to do now? How do you get that? Plus, minus 1. Alright, good. How do you find a third derivative? Show.
Negative 12 times 8 times 4
Good. You got that? Negative 3 times 4 is negative 12. Times x minus 4, negative 2 minus 1, negative 4. You're done. Those are the first two derivatives. Not bad at all. Right? Pretty straightforward. Any questions?
I like to do something in the same
So no questions here? No questions here? Alright. I want to find the first derivative at x equals 1, the second derivative at x equals 1. Alright, so we find the first derivative and the second derivative. So here's what I see though. I see a bunch of square roots here, and right now, okay, well really the only way you can do work with square roots is if it's to the 1/2 power. Because right now you guys only know how to do things with exponents. Right? You want to do it with the powers. So I'm going to rewrite this. It's going to be equal to 1/3. Now since this square root is in the denominator, that's x to the 1/2 down here, but I can't have stuff in my denominator. You don't know how to work with it. So I can bring it to the top. It's going to be x to the negative 1/2. Okay? I have to add to that square root of x plus 1, which is just x plus 1 to the 1/2 power. There's that way. I rewrote that in a way that we know how to work. Okay? So, we need to find, before we even worry about it, it says f prime of 1 and f double prime of 1. So the first derivative will have 1, the second derivative. Before I even worry about plugging something, I'm just going to find the first and second derivative. Okay? So my first derivative, f prime of x, that's equal to, alright? Now again, what am I going to do here? I'm going to do negative 1/2 times 1/3. That's going to be negative 1/6. Okay? That's x. I have negative 1/2 minus 1. Negative 1/2 minus 1. Negative 1/2 or negative 3/2. You like to say, and probably like to use it proper fractions. Right? Plus, we have this 1/2 right here. We're going to take this 1/2 and multiply by 1 outside. 1/2 times 1 is 1/2. And then plus 1. We have 1/2 minus 1, which is going to be 2 here. Nope. 1/2 minus 1.
Oh,
So 1/2. That's our first derivative. Okay. So now we can find our second derivative. So we have negative 3/2 times negative 1/6. That is going to be positive 3/12. Positive 3/12 actually turns into, I believe, 1/4. So did you have that correct? So it's going to be 1/4. Next, I have negative 3/2 minus 1. So negative 3/2 minus 1 is going to be what? Negative 5/2. Okay. Plus, now I have, oops, I have a negative sign here. Negative 1/2 times positive 1/2 is going to be negative 1/4. X plus 1. Negative 1/2 minus 1 is going to be what now here? Negative 1/2 minus 1. Has. Okay, so this in this up is that's equal to 1/4 x to the negative 5/2 plus minus 1/4. What? That's my first derivative. The second derivative on what? My first derivative. Now it says it wants me to figure out the value at x equals 1 to go to this. Right, so all that means is I plug in 1, but let's see that. So it's going to be negative 1/6 times 1 is negative 3/2 plus 1/2 times 1 plus 1 is negative 1/2. In this case, I'm going to take my calculator out. It's going to be negative 1/6 times 1 to the negative 3/2 power minus the plus 1/2 times 1 plus 1 is 2, so it's going to be 2 raised to the negative 1/2 power. Enter. 187. These things sound like compact. So I didn't even do this. Where are you guys supposed to be? Well, they get there a little faster. Want to see this inside the button? Alright. So, down here, alright, so right there we got a value of 1.87. Okay, and then we do the exact same thing. We plug 1 in everywhere here. So that would give us 1/4 times 1 to the negative 5/2 power minus 1/4 times 2 to the negative 3/2 power. What you guys
What
say?
is so-called YouTube?
Oh, you know you do it.
No, I just love it.
I do her every day.
You too good.
Okay, 13 points up there.
Oh my God.
22 on one. Michelle Burns.
So long for out. Oh, you'll get all in the here. Jeremy, so long.
No, I'm so long,
Alright, so we have a couple more problems to look at. Where you want to find the horizontal tangents. Alright, now, this is very important. Okay, so you want to understand what we mean by horizontal tangents. Okay, so, first of all, a tangent line is a line that touches the graph at a point and only at that point. Okay, we understand that, right? So, for instance, if we had this graph, if the graph looked like this, tangent line would be like, well, better drawn, something like, whatever. You get the picture.
I don't think we said about later.
Okay, I'll draw one more time. So, there's a graph, looks like this. Right? The tangent line is a line where it only touches the graph at one point. Right? So, this is tangent right there, because it touches that, so that line right there only touches that function at that point right there. Right? So, a horizontal tangent line, horizontal means this. Okay? So horizontal means like that. So a horizontal tangent line is a line alright, where the slope is equal to 0. Okay? The slope of a horizontal line is 0. So, what we know is we want to find out where the horizontal tangent, or where the slope is 0 for this curve y equals x cubed minus x. So in order to find the slope, we must find what? The v is what we're talking about, the derivative. Alright? So to find the slope of a line at a point, we need to know the derivative. So the derivative of this, dy dx. So Shamar, what would the derivative be of x cubed minus x? Okay?
X squared.
No.
Okay, so mine is. One.
Yes.
And then one.
That's our derivative. Alright? So we learned on Friday that the derivative is our slope. Well, let me rephrase it. The derivative is the function that tells us the slope of f of x at any point. Okay? So it is a function that tells us the slope of f of x at any point. So, don't even plug your hands, but what we want to find here is what x values, okay, what x value is the slope of this function equal to 0. Okay? So, you want to figure out when the derivative is equal to 0. Alright, so, when does 3x squared minus 1 equal to 0? Alright, now, a couple ways to do this. Alright, one way would be to try to factor it. However, I don't think that we can actually factor this. Alright, now, we would think, let's see, I did that, and we zero that time. We can't factor that right now. So what we can do is this. Alright, is we can pull up our graphic calculator. Okay. And take that, and we're going to, we want to know when is 3x squared minus 1 equals 0. Well, we're going to hit y equals. We're going to graph 3x squared minus 1. 6. Okay. Where does this graph equal 0? Well, this is going to equal 0. This time I'm going to hit the zoom and I'm going to zoom in a little bit. Where? Zoom to. Zoom in. Alright, so we can see that this function, 3x squared minus 1, the derivative, is going to be equal to 0 somewhere between negative 1 and 0 to 0 and 1. You can now define those points. So to find those points, those are our zeros. So we're going to hit second trace. We want to find our zeros. Alright? Hit 2. Now it says left side.
I'm sorry, wait, I'll put wait, second trace?
Second trace and then hit 2 zeros. Now it says left down. Left down means go to the left of that 0. So I think keep the node. Okay? As soon as we get on that side, we'll enter. Write down. Go again. Enter. Yes, okay. Enter. So negative 0.577. So I know that this equals 0 at x equals negative 0.577. Okay. Now, that's the only place equals 0. Also equals 0 here, so I have to find that 0. Now, I'll show you. Find the shortcut. So I hit second trace and then hit 2. So it says left down, right? Well, is 0 to the left of this point? 0 to the left of this?
Oh, yeah.
Yeah. So I'm going to hit 0. So the x equals 0. Right down. Is 1 to the right of that point? Yes. 1. Entering. Yes. 0.56. Okay. Alright.
What's the name of your,
So, 0.577. Right, so what we know is that there are going to be horizontal tangents at the points x equals negative 5 or 0.577 and x equals 0.577. Alright? So, we can graph that. This sort of what that actually looks like. So you have x cubed minus x. Now, so we see this. Alright. Does that look like negative 0.577 again? Right here? Alright. So, right there. Okay, those are our horizontal tangents. Because that's where the slope equals 0. So if I take this, right there, Okay, all right, all this up there. So we can see, horizontal tangents. One there. Okay. You got one. Okay. That x value with that line in the graph would be approximately 5.77 and negative 0.577. Alright? We got hard that. Alright. One more example. So again, finding horizontal tangents. Where does the derivative equal 0? Okay. So now I want to write the equation of the tangent line to y equals 3x squared minus 2x plus 4 plus 1 over x at x equals 2. So, then, you weren't here after that. So you gotta pay attention to when they answer this question. We want to write a tangent line. What information do we need in order to do this? Slope and a point. Alright, so to find our slope, what do we have to find? Yes, the derivative. And to find the point, you're just going to plug whatever the x value is into the original equation. Alright? So we're going to have 2 squared is 4 times 3 is 12. Minus 4. So that's going to be 8 plus 4. That's going to be 12 plus 1 half. Is going to be 12.5. Right? So all you do is plug 2 in. Okay? I got you. Alright. So, now, Shamar, you said we have to find the derivative in order to be able to find the slope. Before I can do anything though, this little guy is 1 over x, and that caused me a little bit of trouble because he's trying to be a boss and be down to the denominator. I don't like that. I'm the boss. Alright, so what we're going to do is rewrite this as 3x squared minus 2x plus 4 plus x to the negative first power. So we need to find first derivative. So we need to find dy dx. Okay. So dy dx. Here. What's the derivative going to be from this backboard right here? 6x, okay. What? What's the derivative of minus 2x? Times 2, because it's 1 times negative 2, which is minus 2, and then x to the 1 minus 1. 1 minus 1 is 0, x to the 0 power is 1, so it's negative 2 times 1. Minus 2. Alright, you go on here with the derivative of positive 4. Is it a constant? Okay, what's the derivative of a constant? 0, so it goes away. Now we have x to the negative first power. So we do with x on it. I want the negative 1 times 1 is negative 1, so just put my minus sign there. And then so it's minus 1x, so it's minus x, and then my x out will be what? Negative 2. This is my first derivative. My first derivative, alright, is my function for slope. Okay, cool. I want to know what the slope is at x equals 2. So how will I find the slope of x equals 2? Plug it into what? Into which, I got two equations.
Oh, this thing.
I plug it into my derivative, so I want the slope. So, the slope is gonna be, dy dx, evaluated at, say, x equals 2, so it's gonna be 6, so that's equal to 6 times 2 minus 2 minus, 2 to the negative second power. That's equal to 12 minus 2, that's 10, minus 2 to the negative second power is going to be 1/4. So we're going to have 10 minus 1/4, which is 9.75. That's my slope. Okay. Now, I need to write the equation though. I can't just stop here. So my equation is y minus y1 equals 10 times x minus x1. Okay? So that's y minus y1 is 12.5 equals slope, which is 9.75 times x minus x1, which is going to be 2. Okay, I'm done. There's my equation. I do not need to do anything else. I do not want to risk making a mistake. Now, just because we have the ability, let's go ahead and look at these two graphs. Okay. So, y equals, our equation is 3x squared minus 2x plus 4 plus 1 over x. Enter. Our slope, or our equation for the tangent line is y equals 9.75 times x minus 2 plus 12.5. 6. Boom. There's a window. Let's go negative 3, 3. We'll take the y min to 0. The y max will go to 20. So, do we agree that that line looks pretty tangent at x equals 2? Alright.
Wait, when you plug that in, you plug it plus 12.5.
Into the graph, because on the calculator you can't type this in, so it's y equals all of that, then so that's minus 12.5, plus 12.5. Alright, done. So, your guys' homework tonight. Yep, it's a big one. You don't have any for Monday. Turn down.
Let's go Friday.
The fact that you also have to be taking quiz.
Who?
Your guys' homework is page 124. 1 through 12, 26, 29, 30, 32 to 37, and 39. Calculators may only be used on number 8 and number 12.
Okay.
Or the one that says
Just that whole page.
No, I didn't come over there.
those are up online. You can watch it.
Okay.